Okay, so a couple things about literal equations to walk through, which covers, all right, Module 9 and then Module 10, which deals with some square roots and some set notation. All right, when you're dealing with literal equations, keep in mind that the letter they ask you to solve for is isolated in your answer. All right, the letter they ask you to solve for is isolated in your answer. For example, if they ask you to, they give you the equation, all right, we'll take perimeter of a rectangle because that one's pretty straightforward. 2L plus 2W, 4W. That means when you're done, W should be all by itself. Okay. Okay. Now, the second thing is when dealing with the word problems, all right, you can either use your equation, your original, or your solved literal equation. It's up to you what you want to do. So we use the same equation, P equals 2L plus 2W. All right, of a rectangle. And let's say the perimeter of the rectangle equals 20. And the width equals 2.5. Auto cap. It's going to make my point in a second. So the width is 2.5. And you have to find the length. All right, so I'm going to do my work up here because I don't need to save this for any reason. All right, so method one would be solving and using the literal equation. So P equals 2L plus 2W. All right, and we're trying to find the length. So we solve it for length. So the first thing we do is we subtract 2W from both sides. All right. And what that will do is that will leave, all right, the length, the 2L on the other side. Excuse me, when I do P minus 2W, they are unlike terms. So I cannot put them together. So the result would be P minus 2W equals 2L. Now I have to solve for the L. So I can't have a coefficient. That's the point. So I have to divide both sides by whatever the coefficient is. In this case, 2. All right, so I'm going to divide both sides by 2. What that will do on the right-hand side is it will cancel out the 2 in front of the L. So that's now eliminated. All right, so that's gone. So my final answer would be L, which is what I'm trying to solve for, equals, all right, P minus 2W over 2. All right, so that's what we're trying to solve for. So if we want to find the length, now we plug in these values, and that goes back to evaluating expressions from earlier in the year. So L would equal, all right, and we plug in the values. The perimeter is 20, so that's my 20 minus 2 times the width, which is 2.5. All right, and I divide that entire thing by 2. All right, the result, 20 minus 5, which would be 15, divided by 2 is 7.5. All right, so that would be the value of the length. So that's one way of doing it. Now, if you're just looking for the answer in a word problem, again, they're not asking you to solve for the literal equation. There's nothing stopping you from plugging it into the original equation. This is what I mean. So this would be method 2. P equals 2L plus 2W. I'll plug in 20 equals 2L plus 2 times 2.5. All right, 20 equals 2L plus 5. And then how do you get rid of the plus 5? You, of course, subtract. 20 minus 5 equals 15. So 15 equals 2L. How would you get rid of the multiplication by 2? You would divide by 2. And 7.5 equals L. You have to decide which way is best for you. All right, but in a word problem, when it specifically asks you to solve for it, then you have to solve for it. Okay? Now, second part of it is translating. Couple things to keep in mind. Whenever you see the word is, that's where I put in my equal sign of my equation. Okay? Also, keep in mind the significance of order based upon order of operations. With addition and multiplication, all right, it's not going to matter. Because of the commutative law that we studied earlier in the year, it doesn't matter. Now, the difference is with subtraction and division, order does matter when you do it. So keep that in mind when doing problems. So, for example, when they tell you to translate 3 less than a number, all right? Well, in that case, you're taking 3 away from the number. So you're starting with the number, so that would be the n, all right, minus the 3. All right, so that's what it translates to. Now, if you ever struggle with that, the order in which it is, all right, change it to a mathematical expression. So in your head or on paper, so let's say it would be 3 less than 7, and do the math in your head. Well, 3 less than 7 would give us 4. How would we get the 4? Would we do 3 minus 7 or 7 minus 3? Hopefully you realize you would do 7 minus 3. And then, okay, well, instead of less than 7, okay, it would be less than a number. So that's your variable. So you could just go right back in and change that to the n. And that will give you the structure you need in order to get the correct answer. All right. Now, the last thing I want to talk about, okay, with this isn't literal equations. All right. Obviously, it is consecutive numbers. All right. And a shortcut we can use is use the average or mean value. All right. So this is what I mean. If you have to find 3 consecutive integers whose sum is 75. All right, 3 consecutive integers whose sum is 75. So let's say we got to do that. All right, well, you can just take the total. Remember, to get the average, we add the numbers and divide by the number of numbers. So we take the sum, which is 75, and divide by the number of numbers, which is 25. That, ladies and gentlemen, will always be your median or middle value. For those of you that haven't studied that in a while, median means middle. All right, so what I would do is I would start with my middle value that I just found, which is 25. And when it's consecutive integers, remember they're separated by 1. So 1 more than 25 is 26. And then on the other side, 1 before 25 would be 24. All right, so the 3 values would be 24, 25, 26. So when this is odd, all right, so when that is odd, so the number of numbers is odd, you can divide by, you can find the average to be your middle number. Now, when it's even, it's a little different. Now we got 4 consecutive integers. 4 consecutive, let's say even integers, so we'll change it. Okay? Whose sum is 76. All right, so 4 consecutive even integers. So now it's a little different. Okay? Well, what I would do is I would go, okay, 76 divided by 4, same idea as 19. But realize they have to be even. Okay, they have to be even, and 19 is not an even number. Well, I would take the number before 19, all right, which is 18. And I would take the number after 19, which is 20. All right. Then I would work from there. The number before 18 would be 16. And the number after 20 would be 22. And then add them up. All right. 16 and 18 is 34. 34 and 20 is 54. 54 plus 22 is 76. All right. So it works, but you got to play with it a little bit. All right. So remember, even integers are separated by 2. Consecutive integers are separated by 1. And if you have odd integers, all right, they're separated by 2 as well. All right, so that covers Module 9. All right, now Module 10. All right, Module 10 deals with square roots. right, you have to remember that the square root of a number, all right, is defined as the number that times itself results in the number. All right, now, when n is greater than 1, so when n is greater than 1, the square root of n, all right, the square root of n is always less than n. All right, so that's what gives us the guidance. The square root is when it's a number greater than 1 is always greater than it or less than it. So for example, if n was 9, the square root of 9 is 3. All right, but if you face it, and if they have this problem in here, when n is less than 1, all right, strange things happen. The square root of n actually gets bigger. All right, so keep that in mind when doing problems, that when you have a value between 0 and 1, all right, it goes from there. All right, for example, all right, the square root, all right, of 1/4. And you have to think of what number, all right, gives you the square root of 1/4. What number times itself gives you 1/4? And that, ladies and gentlemen, all right, that is another fraction. Okay. It will not let me get it. The square root of 1/4 equals 1/2. All right. So it actually gets bigger. All right. Now a couple other things. All right. One thing about square roots. If n is less than 0, all right, the square root doesn't exist. Square root does not exist because the square root has to be a number times itself. If we have a positive number, a positive times a positive gives me a positive. If we square a negative number, a negative times a negative also gives me a positive. So basically, all right, this deals with what is called imaginary numbers that perhaps you'll progress to at some point in your mathematical career. The square root of a negative number doesn't exist. It's not real. All right. Now, second thing about that is set notation and set builder notation. The main thing I want you to learn with that, all right, versus interval notation. All right. Greater than or less than. All right. You have parentheses. It doesn't include the values. That's what those mean. Now, when it's greater than or equal to, or of course, less than or equal to, then we have what are called brackets. All right. We have what are called brackets. All right. So and it can be mix and match. One of them can be a parenthesis. One of them can be a bracket, which leads me to the last point, which is a mistake some people are making. All right. Take your time. All right. Remember, the computer is not smarter than you. All right. So basically what happens is, and some of you have done this, some of you talk to me, I'm not singling anybody out because multiple people have done it. If you enter something incorrect, the computer can't distinguish that. The computer doesn't know what you meant to do. All right, so take your time, especially in the assignments that aren't timed. All right, realize the computer will not read it. All right, so obviously punctuation matters in this case. All right, but in previous units, all right, some of you are entering capital versus small letters, all right? There is a difference. All right, as you progress in math, a capital letter usually means some type of calculation. For example, capital P represents perimeter. Okay, so that'll be something that you calculate to get. All right, but please make sure you, and as we progress, when we solve equations, some people automatically put X. All right, look at the variable they give you. If the variable is not X, it doesn't recognize that. All right, so I just want you to keep that in mind as you progress. All right. I hope this helps with modules 9 and 10. All right. And stay healthy, and we will talk to you soon. Bye.